Right. In this unit, we're going to start looking at factoring polynomials. So we begin by looking at the greatest common factor. So find the greatest common factor. So every polynomial can be thought of as made up of smaller terms. So the greatest common factor, abbreviated GCF, the largest quantity, the number, variable, or sometimes both, that divides each term exactly. So let's start by looking at just the terms themselves, not combined into a polynomial. Let's find the GCF between 12x squared and 8x cubed. Now you may remember from an earlier grade where all you had were just numbers. Well, here we're going to be looking at numbers and variables. So let's go and look at this. So let's first look at the number part. So numerically, what number will divide both into 12x squared and 18x cubed? Well, 2 does, but is there anything bigger? Because we're looking for the greatest common factor. 2 does, 3 does, 6 does. So 6 is going to be the numerical value that divides evenly into both terms. And then what about the variable term? So x squared is the highest one. So there we go. All right, so I hope that part helps. Let's do one more. Find the GCF of 8a cubed b squared and 12a squared b cubed. Again, look at the number part first. 2 goes into both of these, but a bigger number would be 4, right? So 4 divides into both of those evenly. And then what do we have here? A squared. We certainly can't be a cubed because this one doesn't have a cubed. And then b squared would be the highest b term we can go into evenly, right? Now let's see in the next set of examples how this connects to factoring polynomials.